Hello, my name is Dominik Szczeciński. I will try to teach you the beginnings of programming, i.e. how to start working with Python. We will do this using the example of tasks that are proposed for the basics of programming in high school or primary school. These are the 13 tasks we have at our disposal here. But before we start, let's talk about how to actually get started with Python. The simplest way is to install a program called Thonny. Thonny is a simple editor where you can write code and see the results. I'll show you that in a moment. You can download it from the website thonny.org. There is a dedicated version available for Windows, a version for Mac, and even a version for Linux. So no matter which specific operating system you currently have installed on your computer, you will definitely be able to work and write your code in this versatile program. After successfully installing and then launching the application for the first time, you will be able to fully configure the program to suit your needs. Of course, you can set it to Polish language if you like. I also suggest starting with the simple version so that we have all these unnecessary things on the menu unavailable. There will simply be less confusion about what to do. When you run the program, it looks like this. We can enlarge it here. And now like this, in this program, we can write code here. We can load it from disk, save it to disk, and run it. The other icons are not important for now. We can also write several codes, meaning we can write here one program after clicking new. Here we can write another program and another one. We can switch between these programs later. When closing, of course, it will ask if we want to save this code. For now, we won't save it. The whole fun with Tone will be that at the top we'll be writing our program. So here we write our program. We try to run it. And at the bottom we'll see the result. If anything appears in red, that means the program has an error somewhere, and at the beginning you'll most often make two types of mistakes. The first mistake is if we try to write something and run it, the first error will be a syntax error. The easiest way to imagine it is that it's kind of like in the Polish language. A spelling mistake, meaning somewhere in our code we have an error like a missing quotation mark, missing parenthesis, or missing colon. These kinds of syntax errors cause our program not to run. The second type of error is one where you'll see the word ident or indent appear somewhere. These messages can vary, but if you see the word ident somewhere, it most likely refers to indentation, which is a standard in Python when writing programs. These indentations should never be made with spaces. We use the tab key. Tony will also automatically handle these indentations for you as long as you write the code correctly. If we write the code in a way that Tony understands, for example, print alla Makota, then at the bottom, after running it, we will see the result of our program's execution. There won't be anything highlighted in red here then. One more important thing. Python is an interpreted programming language, not a compiled type of language. This means that if we write a small simple program and run it, and for example there's an error in the third line, then after running the program, as long as it's not a syntax error, let's say that instead of print, we wrote print with a D. After running the program, you'll see that the first line executed, the second line executed. The program only displayed an error at the third line, so in Python, if there is an error in the program, you can still run the program, but it will stop as soon as it encounters the error. That's how an interpreter works. With compilers, it's a bit different. The program won't let us run, the software won't allow us to run our code if there is an error anywhere. So with a compiler, the entire program must be correct before you can run it, whereas with an interpreter, like in Python for example, the program will run even if there is an error, and it will keep running until it encounters the error. And now, what we're going to play with are these tasks. There are 13 tasks. They are mainly related to mathematics and logic. But maybe let's do it this way. By way of introduction, let's talk about what variables are and what the basic instructions in Python are. To start with, a variable. The simplest way to imagine it is by comparing it to mathematics. So a variable is something like in math. an unknown. So for example, we can set x equals 5, then we write a command to print the value of x, run the program, and it will print 5, because x was equal to 5. Of course, there may be more of these variables. Let's say that a will be equal to 1, b equals 2, c equals 3. We can also write down how many there are, a plus b plus c. We run it and we get the result that's 6. We can also use quotation marks when printing. If we use quotation marks, Python won't calculate it, but will think it's just some text. Here, this text happens to look like a plus b plus c, but for the computer, anything in quotation marks, Tony will display it in green for you. It's simply a string, so if I run it, it will display the text a plus b plus c instead of the result of the operation. We can also write it in such a way that the result of adding a plus b plus c is, here we end the string, then we add a comma, and then we include the expression a plus b plus c without any quotation marks. So in this specific place within the code, the actual numerical calculation will appear. Consequently, if I run this program now, I will get a complete string that shows the final sum. The result of adding a plus b plus c, that's our green text. Right after it, with a space that is added automatically, if we use a comma, the result of the calculation will appear. We can add another string here, add it, and that's nice. We run it, and right here is simply our result. If we change any variables, let's say b is 3, and run it, it will automatically be recalculated here. And now about the variable. It's not a random name because a variable of course can change. And here we can write something that wouldn't work in mathematics, i.e. a equals e.g. a plus 1. It means something like this. In the first line a is 1, in the second line a. We already know how much b is, but a is still 1. In the third line we know how much a is, how much b is, and we already know how much c is, but a is still 1. And in the fourth line something happens. The new a, or in other words from now on, a will be as much as it was up to this point plus 1. So if a was 1, then from the fourth line on, a will now be 2, because that's the one that was already there plus another one. So at this point, a will already be treated as 2. We run it and we get the result 8. Of course, we can change these variables here in other ways as well. Let's say c equals c. C plus a, b equals b plus 1, a equals a minus b plus c. If we were to calculate it in our minds, we should get some result here. Generally, programming was invented so that we wouldn't have to struggle, we wouldn't have to calculate it by hand, but the computer would do it quickly. So if I run this program, I immediately get the result, which is 12. Now let's look at a different example. We can do it in such a way that we name a variable. Let's call it isle. A variable can be any word, but it can't have spaces and it can't start with a digit. So for example, 2 isle can't be a variable, but isle2 could be the name of a variable. If we want to ask, in other words, if we don't want to provide the number ourselves, but want the user to enter it to determine the value of this variable, we can do something like this. We will ask Python to prompt the user for an integer. That's what this int is for. And display the message. Please enter the total number of hamsters you currently have. And in this way, Python will ask how many hamsters you have, and the user will enter some text. Then, using the int function, the computer will try to convert that text into a number. If it succeeds, what will the number be? If it doesn't succeed, for example, if we write 22 in words, then Python will display an error saying it couldn't convert it to a number. Let's try it. I'm running it. How many hamsters do you have? 2! We have an error because it couldn't convert the word 2 to a number, but if we run it and enter the number 2, then there's no error here. If we're asking for a string and not a number, let's say we ask for a name. In this case, we should avoid using the int data type because we actually want to request a string from the user. For instance, we might want to ask a question like, could you please tell me the full name of the oldest person in the group? And now we can display it with print. Eldest. The hamster's name is, and we'll put it here. That is the specific name the user has officially provided, followed by a comma, and he is the one who rules over the entire gang. How much minus 1? Because we don't count the oldest one, comma. Other hamsters. I'm running our program. How many hamsters do you have? 40. What is the name of the oldest? Stanislaw. The oldest hamster is named Stanislaw, and he rules over a gang of 39 other hamsters. This is how data entry works. This is how data display works. We can still use this basic instruction. Conditional instructions, i.e., for executing part of the code that we want to be executed in a given situation and not to be executed, always. And this is the if statement. If in Polish means jeżeli. We can, if the number entered by the user is greater than 40, then we use a colon. And here the indentation is important. I press the tab key. And that means this line will only be executed if the number is greater than 40. We can also do the opposite case, that is, in the other scenario. And now notice, when I write the code and add the colon, when I press enter, the indentation will be created automatically for me. I don't have to remember about it. And here we'll write buy more hamsters. And now, yes, I will run it. How many hamsters do you have? 60? Give me the name of the oldest one. Stanislaw. The oldest hamster is named Stanislaw, and he rules over a gang of 59 other hamsters. I entered the number 60, which is how much greater than 40, so this line was completed. If I run it again, how many hamsters do you have? 10? Stanislaw. Now this line was executed because the number was not greater than 40, so this case was executed. So what if does is check if it's true. If it is true, it does the first part. If this is not true, he does the second part. And here's also a nice example with this error, because Python is interpreted. If we had an error here, that is, if this print was with a D here, if I run our program, how many hamsters do you have? 100, Stanislaw. You'll notice that the program worked without an error, because it never executed that line. So if there were 100 hamsters, this line was correct, and this line determined that this line should be executed, not that one. And because that one wasn't executed, the program ran without an error. And now, if we were to submit such a program for evaluation somewhere, we should check all possible situations before we let this program go any further, so to speak. So we should test it in such a way as to provide cases where there are more hamsters or fewer hamsters, so that every line of the program gets executed, because otherwise we might miss an error that appears somewhere in the program, and we haven't fully tested this program. And now we'll try to do the first exercises from the list. The first task on the list goes like this. Write a program that, given 3 sides, checks whether the triangle is equilateral or not. Then display the answer. So the program should tell us, after asking for the sides, let's call them A, B, and C. So we have side A. Please go ahead and enter the length of side A. We also have side B and side C. What is the length of side B? What is the length of side C? And the program should check whether the triangle formed by these 3 sides is equilateral, meaning whether all the sides are the same. And now, in an if statement, we can't do something like this, although in Python it actually is possible, but generally it's not accepted. In an if statement, we can't check something like this, that is, check all 3 sides at once. At the same time, we can check whether side A is the same as side B. Notice that when we check if something is the same, we use a double equal sign. And if side A and side B are the same, then this will be true. Otherwise, it will not be true. Now, if this is not true, we already know that this triangle is definitely not equilateral. So at this point in our code, we can go ahead and write print not equilateral. So, however, even if we find that these 2 specific sides are exactly the same length, we still don't actually know for sure if it's equilateral, because the third side also has to be confirmed as being the same as the others as well. So instead of just true, we can check that as well. Now the remaining 2 sides. So if B is the same as C, if that's true, then we'll write something here. And if that's not true, then we know that, as you can clearly see from the measurements, this specific geometric shape is actually not equilateral at all. However, if it is true, that is, if A is the same as B and B is the same as C, then we already know that C must be the same as A. Then we'll write print. The geometric figure shown here as triangle ABC is. The three-sided polygon. Equilateral? Okay, I'm running the program. What is the length of side A? 1. What is the length of side B? 1. What is the length of side C? 3. It is not equilateral. Let's test it another way. What is the length of the side? 1, 3. 1. 1 is not equilateral. 1, 2, 3 is not equilateral. 1, 3, 1 is not equilateral. I'm running it again. 1, 1, 1. The triangle is equilateral, and the first task is done. The second task is to check whether, with 4 given sides, we can build a square. You can, because the condition is that all 4 sides are the same, but it doesn't have to be a square, since it could be a rhombus. The question is whether you can build a square, not whether it will be a square. So, can you build a square from the 4 given sides? Next, we should get an answer that if it's not possible to build it, the program shouldn't display anything. So in reality, there won't be those instructions, else. A knife can also work without an else. This task would look like this. There would be one more side, D. And now if A were the same as B, then if you indent here, the computer knows that it should only do the next thing in that case. If B is the same as C, then if we establish that C is exactly the same as D, then we don't actually need to check if D is the same as A, because it logically follows that it must be, since all 3 are already perfectly identical. Then you can proceed to build a square. We run the program. 1, you can build it. 1, 1, 1, 2. Nothing is displayed, which means it's correct. 2, 2, 1, 1, nothing appears, so again it's correct. And that was the second task. Next task. Write a program that checks whether it is possible to build an isosceles triangle from 3 given sides. And here it's already a bit more thinking involved. We have 3 given sides, A, B, C. And now we need to check if it's possible to make an isosceles triangle. Isosceles meaning at least 2 sides are the same. So an equilateral triangle will also be an isosceles triangle. And now we can do it like this. If A is equal to B, then it's possible. Is it isosceles then? It is. If B is equal to C, then it's also isosceles. If C is equal to A, then it's also isosceles. And it seems that this program is okay. Let's run it. 1, 1, 2. It's isosceles. 1, 2, 1. It's isosceles. 2, 1, 1. It's isosceles. But if we input the number 1 into the system, then the program will display a message back to us on the screen. This happens because each of these individual if statements will evaluate the condition and find that it is indeed true, and consequently each one will print the word is. But we don't want the program to do that 3 times. So the way to fix this is to use else. However, this way makes it easy to get lost, but let's do it to show how it works. So in the opposite case, we'll do this. In the opposite case to this, we'll do this. And in the opposite case to that, we'll do is not. And now if A is the same as B, it will print is. And it won't execute the rest. If A is not the same, it will skip that and do this part. And then it will check if B is the same as C. If it is, it will print is. If B is not the same as C, then it will do this part and check if C is the same as A. If it is, it will print is. In the opposite case, none of these conditions were met, so it's definitely not. Let's run it. 1, 1, 1. We actually have the answer. Now, a single one. However, there is a simpler way to program such programs that are supposed to answer us with a yes or no. And this simpler way will be as follows. We introduce one more variable. Let's call it isosceles. To start our logical process right at the very beginning, we'll first assume that the specific triangle we want to check is definitely not isosceles. So, this is our fundamental starting point for the proof. We are going to assume that this triangle does not possess two equal sides and is not isosceles in any way. And now we try to contradict this assumption. If A is the same as B, then we'll say it's isosceles. I'll copy this to write faster. Isosceles equals true, which means we state that it is in fact an isosceles triangle. If B is the same as C, then we'll also say that it is in fact an isosceles triangle. If C is the same as A, then we'll also change our mind and state that this triangle is in fact isosceles. And now, at the end of the program, in this variable, we have either true or false. The result will evaluate to false if absolutely none of these specific conditions have been met. But the final outcome will be true if any of these conditions were met. And now it is finally enough to verify and determine whether or not isosceles equals true. Remember here that with if statements you use double equals, and when assigning values you use a single equal. If isosceles equals true, then we'll write it is isosceles. Otherwise we'll write it is actually not considered to be isosceles. And now if we run our program and enter 111, we're now at the third line. Then the program will assume that it is not isosceles and check whether any of these conditions are met. In this case, actually all three will be, so 3 times. It will determine that it is indeed isosceles, but the fact that it determines this a second and third time doesn't change anything for us, because it already established the first time that it is isosceles. We run it and then press enter, and it determines that it is isosceles. So this little program works in such a way that we make a hypothesis and then try to either disprove it or prove it. Whether to assume at the beginning that something is or isn't depends on the type of task, because sometimes it's easier to assume that something is and then try to disprove it, and sometimes it's easier to assume that something isn't and then try to disprove that, or at least attempt to do so. And now, there's one more important thing here that should be understood in order to program better. If we have a variable, let's say some x, and it is equal to 5, then in this line the variable is called x, or if we ask, what is this variable? It's x. What is the value of x? X is 5. However, not all variables in programming are numerical, so we can ask the fourth variable. What is this variable? Isosceles. What is the value of isosceles? False. Or true, depending on the problem we have. So the value of a variable does not have to be a number. We can do it ourselves too. Variable name equals Dominic. What is the name of the variable? Name. How much is a name? Dominic. And now another thing. If it is constructed so that at this point, what I mark in blue, this must be the answer to how much it is. It must always be true or false. True or false. So A equals B depending on what values we give for A, and B this is either true or false. In the same way, this variable is either true or false. Similarly, this condition is true or false depending on what values we give for A, B, or C. And now, if requires that at this point it is either true or false. If Rho nor Amieni is true, then here we will have true equals true, which is true. If Rho nor Amieni is false, then here we will have false. Equals true, which means false. So no matter what we write here, the important thing is that the result of this operation is either true or false. Rho nor Amieni itself is also either true or false. So in fact, we can write this a bit more simply like this. We don't have to write equals true, because Rho nor Amieni itself is already either true or false. And I suggest you watch the part of the video about true and false. Go through it 3 or 4 times so you can understand how if works. That it works in such a way that here it has to be either true or false. Even if we put some complicated condition here, something like equals this or that, in the end it will still be either true or false here. So if we write it like this, it's a bit redundant. It's like saying buttery butter, because whether true equals true, then it's true, and so on. You should simplify this as much as possible. And actually, if you translate it into Polish, it might even be easier to understand. If it's isosceles, write isosceles. Otherwise, it's not isosceles. And that was task number 3. I suggest going through it once again. Listen to this task again. Alright, I assume you've listened to it a few times with this isosceles true, false, and you already understand why here it's if isosceles and not if isosceles equals true. Although, of course, both notations will work, but programming is usually done this way, so let's move on to the next task. In the next task, we need to check whether the number x is even and divisible by 3. Then display the answer. If it is not even and not divisible by 3, the program should not display any message. So most likely, there won't be an else here. So yes, we ask for a number. Let's say it's a variable, let's call it, and enter the number. And now, to solve this task, you need to understand what divisibility is. If we say that an even number is a number that can be divided by 2, that's not true, because every number can be divided by 2. However, a number divisible by 2 means that when we divide it by 2, there is no remainder. And the easiest way to do this is to use an operation called modulo, and this operation should be understood. Modulo works like this. 9 modulo 4. The idea is that we subtract 4 from 9 as many times as possible. So 9 can be made minus 4, then minus 4 again, then you can't make minus 4 anymore because the number is too small. So what remains is 1. So 9 minus 4 is 1, and from 1 you can't subtract 4 anymore.